Short and sweet, factoring using the difference of two squares. First, a little vocabulary that'll help us with this topic. First of all, we know the difference is generally the answer to a subtraction problem. So we'll always be looking for a subtraction symbol. 2, because we are looking for two terms. Something like x squared minus 9. Two terms and a subtraction. Finally, squares. We are looking for what we know as perfect squares. A perfect square is when we can take a square root and not get a decimal. So for example, 9. Because the square root of 9 is equal to 3, 9 is a perfect square. 16. The square root of 16 is 4, so 16 is a perfect square. 17. The square root of 17 is 4.123. Therefore, 17 is not a perfect square. All right, let's go ahead and factor. So first, some questions. Is it a subtraction? Yes. Are there two terms? Yes. Then we need to know, do we have those perfect squares? Well, the square root of x squared is x. The square root of 4 is 2. So yes, we have those as well. This is the easiest factoring you can do. So all I'm going to do is set up two parentheses. I'm going to put the square root of x squared first. I'm going to put the square root of 4 second. And then I'm going to finish off with one addition and one subtraction. It really is this easy. Let's try another one. Y to the 4th power minus 144. First of all, do we have a subtraction? Yes. Do we have two terms? Yes. Let's check for those perfect squares. So the square root of y to the 4th would be y squared. You can use your calculator. The square root of 144 is 12. So we are good there. So now again, I just want to set up those parentheses, and I'm going to use those square roots. So first of all, the square root of y to the 4th goes here and here. So there's y squared. Then the square root of 144 goes here. And then the only thing that makes these parentheses different is one's a positive and one's a negative. It doesn't matter which one comes first. Now I'm going to let you practice a little bit. Let's put it all together with what we already know. We already talked about GCF in a previous lesson. So now I'm going to look at this one. So as I look here, I do see a subtraction. I see two terms, but for my perfect squares, the square root of 12 is a decimal, so we don't have the perfect squares. So let's think about this. What are the factors of 12 and 3? Well, 12 is 1 times 12, 2 times 6, and 3 times 4. 3 is 1 times 3. So as I look here, I notice they do have a GCF of 3. Okay? But I also notice up here that we have x to the fourth and x squared, which means we've got 4 x's and 2 x's. So if we look at what's shared here, I've got x and x. So I also have a GCF of x squared. So we're going to think about that idea of GCF again. So I'm going to go ahead and take 12x to the fourth minus 3x squared and divide by 3x squared. So thinking here, 12 divided by 3 will give me 4. X to the fourth over x squared gives me x squared. Bringing the minus sign down, 3 divided by 3 is 1, and the x squareds are gone. Remember that this comes to the front end. Now I need to look inside that parentheses. So if I look here, do I have a difference of 2 squares? I do. So this one is going to end up with 3x squared. The square root of 4 is 2. The square root of x squared is x. The square root of 1 is 1. And again, 1 positive, 1 negative. So this question involved 2 kinds of factoring. We had difference of 2 squares as well as GCF. I'm going to let you practice just a couple of those. So in conclusion, we have difference of 2 squares. And if we pay attention when we look at directions of what we're looking at, there's that difference piece, there's that 2 terms, and squares for those perfect squares. And also the fact that sometimes we might need to do 2 kinds of factoring in the same problem.